Okay, so for page 67, it's going to be called Finding Inverses for the title. And then you have a foldable that when you open it up looks like this, so you'll have to cut around the foldable, and then you'll cut these two sections right here so that you can open it up like a little mini book with tabs. And so for the first tab, it'll say table or ordered pairs. For the second, it'll say graph. For the third, it'll say equation. At the top, it says note that every function or non-function has an inverse, but not all inverses are functions. So whenever you go to find the inverse of a function or a non-function, it will have one. But when you go to use the vertical line test on it, it may not pass it, so therefore it may not be a function itself. Alright, so when you open up your first tab for table or a set of ordered pairs, we learned in class today, in order to find the inverse, or one of the characteristics of inverses are that the x and the y are switched to one another. So if you want to know if it's a function, an inverse function, when you switch the x and y, you just have to make sure that the x's don't repeat. So there's two examples here. One of them is a table. So the table for f of x is on the x side 1, 2, 3, 4. On the y side 5, 6, 7, 8. So as of right now, f of x is a function. And if you switch those x's and y's, you get x's are 5, 6, 7, 8. Y's are now 1, 2, 3, 4. Because those x's don't repeat, this is truly also a function, so therefore it's the inverse function. And we write that as f with a -1 exponent, although it's not really an exponent. And then parentheses f. The way we read this is f inverse of x. Now over here on the right, we've got g of x. We have three ordered pairs. It's 0, 2, 4, 9, and 3, -3. So g of x truly is a function, and when we switch those x's and y's, we get 2, 0, 9, 4, and -3, 3. So again, we still have a inverse function. For the next one, when you're looking at a graph, you're still going to switch those x's and y's for the ordered pairs because it could be turned into a table, so you would still switch those x's and y's. Two things, characteristics, first of all, is that the graph of an inverse is a reflection over y equals x. So if you were to flip it over the line y equals x, you would get back the same exact graph. That's one of the properties of inverses. And then also, it says if a graph passes the horizontal line test, it is 1 to 1, so it has an inverse function. So we have not only a vertical line test, but a horizontal line test. And so if you were to take a function and its graph passes the horizontal line test, then it's called 1 to 1. That's actually one of your vocabulary words, 1 to 1. And that means that function is going to have an inverse that is a function. So here our example is for f of x equals x squared. So I plotted a few of the points, 0, 0, 1, 1, -1, 1, and so forth. And in order to find its inverse, I simply switch those points. 1, 1 would remain 1, 1. -1, 1 would turn into 1, -1. 2, 4 would turn into 4, 2, and so forth. And so I graphed it. Now you'll notice that this function, f of x equals x squared, it started out as a function because it passes the vertical line test. But when I find its inverse, it actually does not pass the vertical line test, so its inverse is currently not a function the way it is. So what I've done is I have separated this into two separate domains. One for the right side of the graph where x is greater than or equal to 0. These are going to be your positive x values. And the left side is for the negative x values, x is less than or equal to 0. So if I only take half of this function, let's pretend I only take the purple side of the function only, that actually does pass the horizontal line test, which means when I find the inverse, it will also pass the vertical line test. So if I were to reflect only the purple points, I would get a graph here in the first quadrant the upper portion of this, and that's going to be actually the square root of x. And so this now passes the vertical line test, which means you now have an inverse function. I could do the same thing with the left side. Now I'm going to ignore the purple side and only look at the blue side. And if I take these points and reflect them over the line y equals x, I would get these points, which is the same thing as switching their x's and y's. I would get this blue graph that got in the fourth quadrant now. So now if you are going to look at just this left side of the x squared, you'll get this bottom portion of the parabola, which is the purple side, but just reflected over the x-axis. And so now we have negative square root of x. So if we would have done this from the very beginning, if we would have taken x squared and we would have tried to find his inverse would have actually been the plus or minus the square root of x. This is what's going to undo an x squared function, the square root function. And so we would put a plus or minus because the x could have been positive or negative when it got squared, so that's why there's a plus or minus here. But in order to have it be a function, I don't take both the plus version, which is this purple side, and the negative version, which is this blue side. I would take one or the other. So there are times that you have to make a domain restriction in order to make a function one-to-one so that it passes the horizontal line test, so that when you find his inverse by switching those x's and y's, then it is going to also pass the vertical line test. And then finally, we have just the equation. So if you have the equation, we learned in class today that there is a method that you can use. This is an alternate method that you could also use for times when that method we learned in class, the doll method I called it, when that doll method doesn't work, which there are a few of those cases, we talked about it in class today, when there's x at the bottom in the denominator, then this method doesn't work, the doll method doesn't work nearly as easily. So this is going to be an alternate to that. So the first thing you would do is switch x and y. The second step is to solve for y. And the third step is to replace y with the inverse notation, which in this case is either f inverse of x, y inverse, etc. You can use any letter in place of f or y. So it looks like it has this little exponent of -1, but that's not what we call it. It's not an exponent. It doesn't represent that. We call this f inverse of x and y inverse. So as an example, I've got f of x equal to 4 over -3x plus 1 plus 7. So if we try to do the doll method on this one, we would have timesing by -3 first, adding 1 second, but then we've got that 4 divided by the x. So trying to figure out that operation and using the doll method would be a little bit more difficult. So I'm going to use this alternate method instead. So step 1 was to switch x and y. Step 2 is to solving for y. Now, in order to do that, y is currently at the bottom of a fraction, so in order to get it from the bottom of a fraction, no, I lie. The first thing I'm going to get rid of is this 7, so we're going to subtract 7 first. Now, the y is at the bottom of the fraction. In order to get it out, I need to multiply it to both sides, this -3y plus 1, because it will keep it from being in the denominator anymore. So when I multiply it on the right side, the -3y plus 1 is going to be canceled out. And then I'll have -3y plus 1 times x minus 7 equal to 4. I'm going to now start solving for y. Since y is right here beside the -3, I don't need to FOIL this out. I can simply divide both sides by x minus 7. So now I am closer to getting y by itself. I need to subtract 1 from both sides, so that's going to be 4 over x minus 7 minus 1. And then I just simply have to divide by -3. Now, dividing by -3 is the same thing as multiplying by its reciprocal, so I'll do that instead. So if I divide by -3, I would end up with a complex fraction, and I really don't want to have to deal with that, so I'll multiply by its reciprocal instead. So now I have 4 divided by x minus 7 minus 1 in parentheses, and I'm going to multiply that by -1/3. When I distribute that, I get -4 divided by 3 parentheses x minus 7 plus 1/3. If you wanted to distribute that 3, that's fine, but you don't have to. And then I'll change that y to f inverse of x. And that is it for this page.